TT enzymes don't usually make headlines in beauty magazines, but if they did, they'd probably have a nickname like the rewriters of youth. Short for 1011 translocation enzymes, the TT family, mainly TT1, TT2, and TT3, are a group of molecular editors that regulate DNA methylation, one of the key epigenetic mechanisms cells use to turn genes on or off. While they aren't quite rewriting your genetic code, they're definitely reinterpreting it, and their work plays a quiet but powerful role in how your skin regenerates, ages, and responds to damage. Here's the basic science without the headache. In every cell, your DNA is wrapped around proteins and tagged with chemical marks that control which genes are active. One of the most important of these marks is a methyl group added to cytosine bases in DNA, essentially a silencing tag. Over time, cells accumulate these methyl marks in ways that suppress genes needed for repair, renewal, and antioxidant defense. This is especially true in skin, which faces constant damage from UV light, pollution, and mechanical stress. This is where TT enzymes step in like little molecular janitors. They initiate DNA demethylation, the removal or modification of those methyl tags. In particular, TTs convert 5-methylcytosine, 5-MC, into 5-hydroxymethylcytosine, 5-HMC, a crucial step that leads to reactivation of previously silenced genes. In young, healthy skin, this process is vital for maintaining the identity and function of skin cells, especially basal keratinocytes, the skin's frontline stem cells, and dermal fibroblasts, the collagen producers. These are the guys doing the actual work of keeping your skin firm, smooth, and capable of bouncing back from injury. As we age, however, the expression and activity of TT enzymes tends to decline, and so does the level of 5-HMC in the genome. This reduction correlates with less efficient skin regeneration, slower wound healing, and loss of cellular plasticity, that is, the ability of cells to adapt and take on new roles when needed. In essence, TT dysfunction contributes to cellular stubbornness. Instead of rallying to repair UV damage or produce fresh collagen, aging cells become passive, inflexible, or worse, senescent. Think of it like a group of factory workers slowly forgetting their job descriptions. Without sufficient TT activity, the epigenetic memory of youth fades. Genes involved in proliferation, detoxification, and extracellular matrix production are silenced, while inflammatory and pro-aging pathways may become more active. This isn't just about looking older. It's about your skin losing its ability to function as a resilient, self-renewing barrier. Enter vitamin C, which acts as a cofactor for TT enzymes. It enhances their catalytic activity by maintaining the iron in the Fe superscript 2 state that these enzymes require. When vitamin C is abundant, TTs become more efficient demethylation machines, reactivating youthful gene programs and promoting more dynamic skin regeneration. But even in its absence, TTs don't stop working entirely. They just work a lot less effectively, like a crew trying to paint a house with dry brushes and no ladder. Interestingly, skin conditions like psoriasis and certain forms of dermatitis have been linked to dysregulated TT activity, showing that these enzymes aren't just relevant to aging, but also to abnormal skin growth and inflammation. In models of psoriasis, reduced TT function has been tied to hyperproliferation of keratinocytes, meaning cells multiply too fast without properly differentiating, while in aged skin, it's the opposite. Cells don't divide enough, and the regenerative machinery stalls. This duality suggests that TT enzymes don't just promote cell growth, but help balance it. They modulate the expression of growth factors, cytokines, and structural proteins that coordinate when skin cells should divide, differentiate, or rest. In many ways, they're the conductors of the skin's renewal orchestra, fine-tuning the tempo so cells aren't playing too fast, as in hyperplasia, or too slow, as in senescence. In the bigger picture, the loss of TT function is now considered a hallmark of epigenetic aging, not just in skin but across tissues. Researchers are even exploring how reactivating TT activity, either through compounds like vitamin C or novel gene therapies, might restore regenerative capacity in aging organs. In other words, TTs aren't just about keeping you wrinkle-free. They may be central to broader anti-aging interventions, regenerative medicine, and even cancer prevention. So while TT enzymes don't show up in your skincare ingredient list, they're quietly directing the backstage crew that makes sure your skin cells remember who they are, what they're supposed to do, and how to keep the show running. Whether they're supported by vitamin C or not, TETs are the reason some cells stay forever young, while others call it quits far too soon.